Welcome to the South East Rivers Trust Story of Rivers webinar, episode 6.2, which is part 2 of our Fish Passage webinars. All of our webinars will be shared on the Surt River Club Facebook group and also via our YouTube channel. And we're a grassroots environmental charity dedicated to improving rivers across the southeast of England. If you have any questions, either throughout the webinar or afterwards, then please ask them by typing them into the Facebook comment section below, and we'll try and have a Q&A session with our staff soon. I'll hand over to Toby now to take you through the rest of the webinar.
Thank you, Jess. I'm Toby, Head of Ops at the Trust. After studying fish at uni, I basically worked as a contractor delivering river-related construction projects. I've now been working at the Trust for coming up to 8 years as part of the delivery team. For all of this time, I've been working on a really cool project called the Hogsmill Connectivity Project. What we're looking to do is basically try to get passage along the whole length of the main river. So far, we've addressed 18 of the 19 barriers, so we really are getting there. And I've also worked on various other fish passage projects across the Surt area. So, what did the fish say when it swam into the wall? Sorry to use the joke end, but I do love it, and it sets the scene well of what we're going to discuss. So yeah, Chris ran through the theory behind why fish passage is such an important subject in the last webinar. If you haven't watched it yet, I suggest you go back and have a watch. It's really good. So I'm going to pick this up from that point and give you a whistle-stop tour of how about we at Surt go about achieving fish passage across the southeast. What I'm going to do is basically include a brief overview of the various options available to us in our armoury. And this is going to include barrier removal, small-scale easements, large-scale easements, and technical passes. Chris left off by saying how weirs are so detrimental to fish passage, so this is where I'm going to pick this up from. Also, in another previous webinar, Nick and I covered the impacts that weirs cause on natural processes. So yeah, have a watch if you want to learn more on that. So what could be better to provide passage past the barrier than to physically remove it? Kind of nothing. Unfortunately, we don't get to use bouncing bombs or explosives. I appreciate that weir removal can be a contentious issue, and it may not always be suitable or desirable. But having said that, I still find this the most satisfying aspect of my job. It's noisy, it's destructive, and hugely satisfying. I'm going to kind of run through a few of our money shots now. Not only do you know that you're providing unhindered passage, but there's also the other benefits associated with the removal. It's amazing to see a river emerging once again from the pond-like habitat. The river can run free again and fish can be free. And although all these shots show excavators, in reality many weirs are small and easily removed with the selection of hand and power tools. So the benefits of removal, well, you know you're going to get passage without any doubt. By removing the structure, generally speaking, you're also removing the ongoing maintenance liabilities, including blockages. If you have, you basically have no efficiency concerns of it not working as it should be, which is a problem with passes and easements. By removing the impoundment, you also bring habitat benefits upstream. Natural processes are reinstated, and there is a good chance that doing so, you're going to help provide gravels for spawning habitat further downstream. So here's some shots of a couple of weirs in the headwaters of the Hogsmill, which we took in 2013. And this is what it looks like once the weirs were removed and the channel had a chance to renaturalise. Now, this is the physical response, but in this case, we've also can demonstrate the biological recovery really nicely too. So Chambermead is a site just upstream of both weirs. The EA fish data shows that there are very low numbers of only one species, the stickleback, in 2012. We then came in, removed the weirs in 2013. Now, the 2016 data really contrast the baseline nicely with the appearance of 3 new species, the bullhead, minnow, and an eel, some of them in really good numbers too. So this data helps to demonstrate the impact that barriers have by fragmenting populations and limiting their dispersal. But on the flip side, it's really reassuring that it also demonstrates that recovery is possible. But unfortunately, removing the barrier may not always be physically or financially viable. This is where easements and passes come in. What we're looking to do is basically either modify the structure to alter water levels in order to provide passage. Each pass or easement will very much be site specific. Many of the principles are universal, but most passes will need to be designed and fitted with the site in mind. This will change according to a load of factors such as the use of the structure, the height of it, which we call the head drop, the range of flows that it needs to work through, and what constraints may be associated with the structure, such as adjacent infrastructure, high flood risk, or needing to maintain upstream water levels, for example. For these reasons, easements and passes come in a variety of shapes, sizes, and complexities. There will also possibly be a number of ways to achieve passage at any given site. So the most suitable solution will need to be decided on, and obviously budgetary constraints will be quite a factor to take into account. A key factor when deciding on the easement and pass that it needs to be suitable for the species present, and also importantly what we're aspiring to. Different fish have different swimming abilities and styles, which Chris has previously spoken about. They also come in different sizes, which the pass must be able to accommodate. Feeding into this, there must be the correct hydraulic conditions within the pass. Excuse the pun, but fish are finicky. For example, different species swim at different maximum speeds, so velocities in the pass must not exceed these. Some fish cope with turbulent flows better than others. Some can leap, others move along the river bed. And finally, attraction. In order for the fish pass to work, they must be able to find it. What I'm now going to do is run through some easements, both large and small, but before I do, eels are fish too. Their numbers have plummeted by about 95% over the past 30 years. Various factors contribute towards this decline, but barriers blocking their migration is a significant one, so these guys definitely need our help. Despite coming all the way from the Sargasso Sea, the juveniles are not strong swimmers. They take advantage of the slow-moving water in the boundary layer on the riverbed, and are very capable of wriggling and crawling over wet substrates. However, smooth surfaces such as concrete and fast-flowing water are not their best friends. So that's why eel passes are a standalone type pass constructed specifically with eels in mind. The aim of the eel pass is to essentially provide them with slower flowing water and a substrate for them to get in and amongst. Eel passes essentially come in two main basic forms. They are the bristles on the left and tiles. Eel passes are definitely site specific. From these simple starting points, their appearance and functioning will differ massively. There is the small scale and simple, the long and the longer, the horizontal fixed and the vertical lift out. There's the professionally customized, fabricated, galvanized or stainless steel versions like on the left, and on the right, the improvised bodgers using off-the-shelf parts from DIY stores. And where sites are tricky, the routes can become really convoluted, or when they can get more technically complex when incorporating traps to help monitor numbers, or where an electricity supply is required to power pumps to provide the flow of water. Now, we often get help with our trusted band of volunteers to help install and maintain eel passes. As generally speaking, they can be installed in anywhere between a few hours to a couple of days. They only require hand tools and are definitely a fun day out of the office. Eel passes typically come into what I call the small scale easement category. Now, I'm categorizing small scale easements as those that are kind of modest modifications to the structure that can be done with some willing people, power tools, and generally a bit of hard grunt. They are great activities for angling clubs, interested communities, volunteers all to get involved with. They're generally low cost-ish. They may not require a great deal of technical ability or know-how. They tend to be simple, so there's less pitfalls with them, but they may not always be 100% theoretically perfect. But, and this is the important part to remember, they are basically making the best of a bad situation. Where weirs can't be removed, the next best thing is to notch them. This is where we cut out a portion of the weir, either to lower the head and make it easier for fish to pass, or if water levels are low compared to the width of the structure, to focus the flow into a passable section, which we call the notch. By notching weirs, we can also change the flow from plunging, which is not so good for coarse fish, to streaming, which is much better. Now, out and about, we frequently come across concrete slabs in the river that create a low head weir, or due to a combination of low flows and over wide channels, result in incredibly shallow water, which creates a barrier in its own right. If the concrete is on a slope, the issue of shallow water can be exacerbated by becoming fast flowing shallow water. Now, some of these structures cannot easily be removed due to surfaces being present. For example, the one at the top left is the concrete protection formed over a foul sewer. They may also be financially unviable to remove because they form part of a bridge footing, as is the case in the top right. Or access can be tricky, therefore making it expensive to get machines and materials too. Furthermore, they may only be kind of temporary barriers during low flow conditions, which makes it difficult to justify a big capital outlay, especially when there's no shortage of other barriers out there. Some passage is better than none, but extending the window which is passable for is definitely favourable. So this is where baffle easements come into their own. What we're looking to do is basically increase the depth of water and, where necessary, also slow the flow. The water flowing is then focused into a central notch for the fish to pass through. In the case of concrete slabs, we may also cut a wedge out of the lip of the concrete in order to help create streaming flow conditions. Now, over the years, we've used various materials for baffle solutions. Like Mark 1, we use curbstones. We then adapted this to using coping stones due to they've got a really nice rounded profile, meaning they don't collect debris. And if they do, it kind of sheds readily under higher flows. We've also used stones, well, probably more accurately, more like boulders. Then there's the recycled plastic baffles, which are our favourite tool in our armoury. They're great to work with, quick and easy to install, and create lovely flow conditions. And we've used them on a number of small easements to good effect. Now, at some point, we're going to have to make the transition from what we call small to large scale easements. It is an arbitrary decision, but I'm going to go for about now. Still remaining with baffles, but this is when the scale of the work steps up and becomes a little bit more involved and complicated. So, for instance, both of these projects, we needed to dam off the whole river. Now, these types of baffles are called low-cost baffles, though please don't be fooled by the name. They're not always necessarily that cheap, but certainly less expensive than the more technical fish pass solutions. Low-cost baffles are increasingly kind of being rolled out across Environment Agency standard front weir gauging stations. They offer the compromise between maintaining gauging accuracy while also providing passage. The arrangement is, generally speaking, standardised, and the use of plastic is definitely becoming the norm. However, saying that, the photo on the left shows wooden baffles. Now, without going into the details of this project, this is an easement that we installed on a non-standard weir, which required an experimental and novel solution using a different arrangement of baffles. Now, this kind of demonstrates the principle that easements are making the best of a bad situation. There are no real alternatives in this case. The theory behind the approach was certainly unproven, but we just had to do something. So we were fortunate, and we teamed up with Durham University to undertake some robust monitoring. To cut a really long story sideways, the technique was successful and it did enable passage. And we could also use this monitoring program as a surrogate for assessing the possibility of the next small easement upstream that we had previously installed. And from this, we can conclude that it was also made passable through the work we did. Now, this is just it with easements. The budget or ability is rarely there to monitor, although as much as we would like to. Instead, it's good to simply rely on a visual assessment of what looks right, and if needs be, keep tinkering and tweaking it until it does. Also, at some point, we've got to switch from baffles to the term pre-barrages. Although they're essentially the same thing, it's just a case of an increase in scale. Here we fix lines of boulders to the bed of this concrete channel of fast-flowing shallow water. Although these photos are taken when the channel was dammed off, I must add at this point. But when you scale baffles up, they can start to be used to drown out impassable weirs by raising the water level over them. As you can see in these photos, where the upstream weir disappears in the after photo. For even bigger barriers, the principle remains exactly the same. It's just a case of upping the scale. This time we're using boulders weighing well over a ton each. As before, we provide a notch in each line for the fish to pass while arranging the boulders in a manner to promote suitable flow conditions for the target species. We've also got to do this while making sure that they're structurally sound and robust, given the absolute battering that they're going to take in flood flows. Now, these are known as pool passes, or in this case, close to nature pool pass. The rock lines are the pre-barrage, the space in between the pools. The barrages step the head down in passable increments, with the pools in between used to dissipate the power of the flowing water and to provide the fish with the opportunity to rest. In this project, we backed up river levels by approximately about 600 mil to drown out the weir, which is just about visible at the back of the shot on the left, and to partially drown out the sloping concrete bed above. Where the impounding effect of the pre-barrage ended, we used recycled baffles to continue the provision of passage further up the river. This is another example where pre-barrages, similar to the previous boulder examples, but this time using oak. The black strips in the photo on the left are the eel bristles that we provided as well. This is still an easement, but it's approaching becoming a technical pool pass, although there is a large grey area in between the two. Change the format of the pre-barrage a little again, and we have rock ramps. This is kind of becoming our signature move at CERT. These are really quite an attractive way of providing passage, both visually and audibly. They appear natural and offer some habitat benefits. They come from the small, as shown in this photo, to the bit bigger still, and then the massive. We have some cool time-lapse imagery of this ramp being constructed if you want to go to our website or follow the link below. So this is what it looks like and how you can kind of see how it functions. In this case, we raised the upstream water level by about 870 mil. There's nice streaming flow through each of the notches, and it provides plenty of resting opportunities along the length of the pass. Finally, on the subject of large-scale easements are bypass channels. This is when a new channel is constructed around the barrier. In the photo on the left, you can just about see the weir coming in on the left and the new bypass channel coming in from the right. The photo on the right shows the channel just a couple of years later, once it's had a chance to naturalise and vegetate up. With bypass channels, what we're doing is the head of the weir is lost over the length of the channel, but attention needs to be paid to the gradient. Too steep and the velocity will be too great for the fish to pass, and it may also result in a kind of ongoing erosion issues. Too shallow and the water will be slow and sluggish, which will result in attractant flow issues at the downstream end, meaning the fish struggle to find the pass entrance. A big limitation of the bypass channel, generally speaking, is the large area of land often required to make them work, although this will obviously depend on the head, which is needing to be accommodated. But on the flip side, there's a massive opportunity of them, is that we're able to create valuable habitat, notably spawning habitat, which may be lacking in a system heavily impacted by weirs. Now, we move on to technical passes. These are more technical, hence the name. They require more calculations, kind of hydraulic and structural, likely to involve civil engineering of some kind to install them. You require consent from the EA Fish Pass panel, and for all the above reasons, technical passes are inherently more expensive and therefore more limiting. They can broadly be categorized into being either fish lifts, but these are more relevant to large-scale reservoirs and not applicable to our rivers, baffle fisheries, also known as fish ladders, and pool passes. Now, fish ladders come in various shapes, sizes, and pros and cons associated with each, so considerations needed to select the right one. Their real strength is they are great at providing passable flow conditions over more sizable head drops within a short length, therefore a steeper gradient than easements can deal with. Plenty of calculations are required to ensure they're effective, taking into account the likely flow ranges you're going to experience. There's lots on baffle sizes, the need for resting pools, as well as siting the entrance correctly. To be fair, CERT has limited experience with fish ladders, apart from this one, which we adjusted when we lowered the head of the weir. By doing so, we made the pass more effective by shallowing the gradient and shortening the length of the pass. But we are currently working up a couple of projects that we are going to have to look to install technical pass solutions on. Similarly to fish ladders, pool passes come in a variety of forms, shapes and sizes. Again, which to go for depends on largely what your target species are and what the site conditions are. Considerations such as velocity, the type of flow and power dissipation in the pools all need to be considered. And there's loads of technical maths involved, which is never my forte. So instead, here's a practical illustration of one at work. So this is an example of the most technical pool pass CERT has delivered. It's a beast measuring at over 60 meters and works in combination with the largest rock ramp that you just saw the video of. It's at the Hogsmill Sewage Treatment Works, but due to the closed nature of the site, not many people have seen it yet. So we're going to take this opportunity to kind of give it a view now. A proper rundown of the project is well beyond the scope of this webinar, but there's a series of blogs on our website if you're interested in having a look at those. So this video was taken before the rock ramp was built, hence that's why there's that big drop at the downstream end. The site is a complex one. It incorporates 3 weirs over about 100 meters of heavily modified concrete channel. The flow was spread over a very wide concrete base, resulting in very shallow flows which create the barrier in their own right. What we're needing to do is basically retrofit this pool pass to the existing channel. Not an easy task. To be fair, it was a proper head scratcher. We designed this with the local EA Fisheries Tech Spec, Dale Clifton Day, who also sits on the Fish Pass panel. Once the theoretical concept was arrived at, it was given to the structural engineers, Crouch Waterfall, to specify how it's going to be constructed in order for so it didn't fall over come the first flood flows. The guys at Land and Water then came in and did a brilliant job to install it over a very long and very hot 9-week period. The solution was to essentially create a smaller concrete channel within the existing channel. Well, you kind of can't polish a turd. The weir at the upstream end then focuses all low, moderate flows down the new channel, and at intervals along the length of the pass, crosswalls form the pre-barrages backing out the water to provide suitable depth through the length of the pass. And we also fitted cobbles to the bed for the smaller species and eels to traverse the pass, as well as eel bristles through each of the high velocity notches. And finally, the last technical pass, which like the fish lift is not at all relevant to our little weirs, is the fish cannon. This may sound like a joke, but I recommend you go and have a Google search of it. I hope you've enjoyed this brief whistle-stop tour, and I hope it helps to inform and inspire more fish passage solutions.
Thanks, Toby. If you have any questions, please remember to type them below. This will help shape our future webinars, and also we can do Q&A sessions. So next time on The Story of Rivers, we'll be looking at tackling road runoff, which is not something that a lot of people have heard of, so hopefully you'll find that very interesting. Thank you very much for joining us, and yeah, we'll see you next time.